In the first two parts of this presentation, we illustrated the specification capture using dWebSpec, which led us to a specification blueprint. It is the implementation of such blueprint that is illustrated in this section, as well as the summaries and conclusions. We have seen the start of the specification with the content source. With the continuation of the capture with the descriptors, these combine to provide comprehensive capture of the specification. It is this specification that would be converted to the specific syntaxes of the target platform. What is needed for this conversion is a dictionary which identifies the equivalent between dWebSpec specification items and the target platform syntaxes. This translation might lead to a wide subject even for a small application like the one we are presenting. There are various reasons for the depth of the subject matter on different platforms. For instance, there might be no direct equivalent on a specific platform, whereas the implementation group might develop a coding pattern for the implementation translation. There could also be alternatives which could be narrowed down with coding standards within a group. What we are going to demonstrate is the ease of implementation of the specifications, as well as the fact that this could be reduced to written coding steps or standardized within a programming group or enterprise. We shall illustrate the implementation on 3 popular platforms. As we mentioned, this could be an expansive subject. We shall use the implementation of a single element for the demonstration. The element we use for this demonstration is the name input text, and the first platform we shall explore is the classic struts. As previously mentioned, the starting point is the content source, which in combination with the representations and the descriptors becomes the blueprint for the implementation. Starting with the representation in the source content, this blueprint is then converted or translated to the target syntax. These translations are as follows. The dWebSpec element of type input text is represented in struts with text tag in the HTML tag library. The value binding using struts terminology is equivalent to the form bean name and a property. The dWebSpec enable attribute corresponds to the inverse of the disabled attribute for input. All the specification captures for the name element have been implemented using this tag. The converted source content would be in a JSP file. The validation specification would be reflected in another file named validation.xml. Struts validations are stored in 2 external XML files, one that stores the validation rules, the other that stores the usage of the rules within the application. A partial listing of the usage of validation rules on this page are shown below the source line. The starting point is to register the element using its identifier as a field within a form. This is entered in the field property as shown. The specified validators involving maximum and minimum lengths have equivalent standard validators within struts. They are specified within the depends attribute. Their validation parameters have placeholders within the template. The required specification is also specified within the depends attribute. This validator does not have parameters. One last entry involves the validation messages. Classic struts needs the field caption for the automatic error generation. This caption is also expected to be in the externalized form as a default. Another popular platform is JSF. The starting point, as usual, is the content source in combination with the descriptors entries. This is then converted or translated into JSF syntax or components. These translations are as follows. The dWebSpec element of type input text is represented in JSF input text component of the HTML, shortened as H, component library. The component identifier is represented. The dWebSpec enable attribute corresponds to the inverse of the disabled attribute for input. JSF is component-based, and the validations would be reflected on the validation components. The validate length component handles both the maximum and minimum lengths, whereas the required specification would be reflected in the required attribute of the input component. The use of validation components rather than external configuration files makes JSF entries relatively simple and terse when compared to struts. However, classic struts includes features like externalization, internalization, error customization with captions, as well as server-side or client-side symmetric validation within these configurations. In short, the JSF translations are relatively easy, but additional translation would be needed to accommodate some of the areas that are part of the strut's basic configuration. We will now illustrate the implementation of our sample element on ASP.NET, a popular Microsoft platform. The starting point, as usual, is the content source in combination with the descriptors entries which constitute the platform. The blueprint is then converted or translated into ASP.NET syntax. These translations are as follows. The dWebSpec element of type input text is represented in the ASP.NET text box component of the component library. The component ID is represented. The value binding is entered into the text attribute of the component. The dWebSpec enable attribute corresponds to the enabled attribute for input. ASP.NET is component-based, and the validations would be reflected on the validation components. There is no explicit length validation component, however the regular expression validation would serve, whereas the required field validator would be used to implement the specification of input required. Unlike struts and JSF, ASP.NET does not have inbuilt the concept of automatically generated error messages that are configurable in resource files. The specification of error message is simply entered into the error message attribute of the validator. Just as is the case with JSF, if externalization and internationalization are to be introduced, there would be more entries and transformations. We showed in this presentation how dWebSpec was able to capture every aspect and details of the requirement of our sample application. The representations in source contents and descriptors are concise and in forms that are easily recognizable to all potential collaborators from the requirement gathering stage up to implementation. Specification capture was shown to be without regards to platform. The specifications could actually become the basis for platform selection. All in all, the artifacts and process provide structured approach that place specification and blueprint before implementation. The implementation is also reduced to translations that could be dictionary driven. This simple example is meant to bring out the salient points of dWebSpec, whereas like any good modeling scheme, there is a greater depth to dWebSpec specification repertoire. There are many areas not included in the specification of our sample application. For example, there are the aspects of security specification for which dWebSpec provides attributes for specifying roles and user principals allowed access to specific actions. Specification of type of event like redirect, postback, immediate or non-validating requests. Pages could also be specified as sequence for which their specifications like validation specifications could be affected by their positions within the sequence. Also, elements within a page could be part of a group and have group specification. Beyond the simple segment presented in this example, segments could inherit from or include other segments. dWebSpec could accommodate such specifications as well as master page, tiles, and template specifications. Just as we showed that segment presentations could be affected by behaviors, they could also be affected by events. Such events as AJAX request or partial refresh. These also have placeholders within dWebSpec. Data interchange with the server could also be effected through URL query strings and parameters. An in-depth coverage, an introduction to the dWebSpec specification, is provided in our free PDF manual for download, Introduction and Guide, available on our website. For more information on dWebSpec, please visit our website, www.structuredwebtech.com.